And I'm really grateful for this interview because I'm learning a lot. But I'm curious because, with the enthusiasm that you're showing, and as a co-founder, of course, that's very different from the enthusiasm that your team must have, because they're your team members. right? They're not co-founders. How are you able to transfer this enthusiasm, if you will, or how are you able to influence them to make sure that they're onboarded, they know what to do, and they know what should the outcome be?
Yeah, this is actually a really, really important subject that we really focus on at Kaylee, right? Because when you work with somebody, right, the incentives sometimes don't align, right? Because like you're a co-founder, you stand to gain a lot of the benefits, right? But the thing is, like, benefits are not always monetary, right? Yes, that's part of it. You have to, compensate them well, and you have to make sure that you recognize them, and then you give them raises and things like that, right? That is a very, one-dimensional component. Right? Compensation is one-dimensional component, right? And the way that I really truly think about this is that you can align and you can excite team members in a different way, right? And that really comes down to how you communicate the problem that you're trying to solve, right? And if you're truly trying to solve a meaningful problem, and the people that are writing applications and code that are going, hey, you know what? Like this piece of code is going to affect this change. They have a direct relationship to that. Right? And if they see that someone uses that, they feel like enormous amount of joy. That is like outside of the monetary value, right? So, but it's all about how you communicate it and being able to transfer that kind of feeling to them, right? So what we do during the onboarding process is on the first couple of days is I literally sit down with them, and every single one, I have like a one-on-one for like with everybody. And that's actually super important because you not only have to get to know the person, but you also have to get to know where their strengths and weaknesses are. Right? Because everybody has it, right? And you have to kind of be comfortable openly asking them these questions, and then in a very empathetic way, like just say, hey, you know what, these are okay, because we have to work with them, right? And we have to work with these, flaws, and they have to be able to like raise their hand and say, hey, you know what, I have this vulnerability, right? Because you don't want everyone to hide. Then you just set up this Swiss cheese kind of like foundation, and everything collapses when you build a lot of pressure on it, right? So the way that we do this is I sit down with them and I literally explain to them the actual problem, no code. It just, I explain to them what happens in an American dental office. I explain to them where the problems are. We even get to read about the problems because we have this review thing called like Google reviews and also Yelp reviews, where patients of the dental office would go and leave review about the problem that we're solving. And it's like a 1-star review. And it's never about like the doctor doing like a bad job on clinical. It's always about how the office give them the wrong estimate and then charge them more for it later. But that's because the patient didn't understand the process, right? And also because the office did not have a complete information. They're working off of like estimates, and they're working off of like incomplete information that is very difficult to obtain, right? So a lot of the really difficult work gets really misunderstood, right? So these are the things that I communicate very openly. Like literally we will like show the pictures of like office managers and like people that are in the office who's working, so they get this like interpersonal kind of relationship to how they go about day-to-day life. So it's not, when you work with Kaylee, right, it's not just about you come in, you get your assignment, and with like the sprint tickets and things like that's not how it works at all, right? Like that's like probably like 1% of it, right? The other parts are like, okay, what are we building and how does this affect the individual, and what are we shipping to make that change, right? And that's always the conversation. So no matter who you are in Kaylee, if you ask them, what is the problem that you're solving, they can actually tell you what the problem they're solving. It's not just what the code they're writing for, right? Because they can actually know what it is for, right? And dentistry is actually really complex. And I'm really, blessed actually, also like, privileged that these team members understand the American garbage of the American dental industry, and then really being able to like interpersonally relate to it and go, oh, you know what? Like, yeah, that really sucks. I don't have that problem here. I'm like, yeah, I know. Sorry, this is America, and we have American problems, and it's like worse. So I think that's typically how we do it.
I know that I've been hearing like positive feedbacks from you, but would you recommend KodeAcross to others? 100%.
Yeah.
Thank you.
Yeah.
Why would you recommend?
Selfishly, I would want to keep using KodeAcross and your capacity internally.
Mhm.
So it's like, yes, let's use more of KodeAcross for Kaylee.ai. I sort of don't want to share you right now, but
Okay.
obviously yes, I would highly recommend.
And as I hope you enjoyed that interview that I had with Jonas, again, the founder of KodeAcross, and we continue to look for
meaningful partners, meaningful projects to work on, reach out to us at KodeAcross.com, and together, let's build meaningful apps that change the world.
Everyone, Seiji here, the technical lead of KodeAcross. So, question is, how is it working with KodeAcross? Para sa akin, I would say it's very fun and challenging to work with KodeAcross. We have a lot of different clients, and these clients are very diverse. They have their own requirements, own objective, and at the same time, they're using different technologies to build their application. And for me as a technical lead, it's very challenging. Kailangan matugunan ko yung mga requirements nila, and at the same time, I should help them achieve their goals and objective by building their applications. And these are challenges that are on the way with our company. But this is also the way for me to learn and keep me up to date with the latest trend, and at the same time, to put me out of the comfort zone and out of my box. So, this is one of the opportunity that KodeAcross has given me. But yeah, we also have a lot of challenges. But despite of these challenges, nagagawa ko pa rin yung mga gusto ko. My life is flexible, my time is also flexible. I can do all of my hobbies just like playing games, biking, watching movies, and other stuffs that I want to do within my life. So, KodeAcross makes this possible. Even though I'm in the Netherlands, I can also do remote work as a technical lead. And this is one of the main objective and one of the main goal of KodeAcross. Building professionals throughout the world. So, if you want to learn more stuff, and if you want to be challenged, join us here at KodeAcross.
Hello everyone, I am Brian Tabares, a software developer at KodeAcross, and have you ever found yourself waiting for a script to finish while there's so much more that you could be doing? Yes, me too. So we'll be diving into concurrency and parallelism in Python, where you'll be learning how to use Asyncio, multi-threading, multiprocessing to make your code run faster and handle more tasks efficiently. Imagine the possibilities when your apps can process requests in a flash. Are you ready? Let's build meaningful apps that change the world. Hello everyone and welcome to our Tech Talk. I'm Brian Tabares, a software developer at KodeAcross, and today I'm gonna teach you the concepts, the definitions, and I'm also gonna show you different examples in Python code of asynchronous programming. Right. So before we start deep diving on how an asynchronous program looks like in Python, we're just gonna need to set our definitions straight. I'm gonna give you the definitions of the concepts that are relevant in asynchronous programming in Python. So first we must differentiate between synchronous and asynchronous programming. By its definition, synchronous tasks are executed sequentially. Each task waits for the previous one to complete. So a very good example of this is, imagine you're in a restaurant and you're in a line at the counter trying to order for food, and it's going to be your turn to order for food. And after you give your order to cashier, you're just gonna stand in line. You're just gonna wait, and you're just gonna wait for your food to come back from the kitchen. You're not gonna look at your phone. You're not gonna sit at the table. You're not gonna talk with anyone. You're just gonna be focused on waiting for your food. So that's how I want you to imagine what synchronous programming looks like. On the other hand, asynchronous task can be initiated and run independently. The program can continue executing without waiting for your current task before you move on to another task. But in asynchronous programming, maybe you can start one task, or uh, like you order your food and then you're gonna wait for that, and while you're waiting for that, you're gonna do other things like sitting at the table, right? The scenarios that I gave you earlier. So that's how we define synchronous and asynchronous programming. So this is how it looks like on this illustration. So in synchronous programming, we have here three tasks, and the blue one, the green one, and an orange one. So before the green task executes, it's gonna wait for the blue task to finish. Also, for the orange one, it's gonna wait for the green task to finish. So it's very sequential. It's waiting for the task to finish before it starts another task. So synchronous programming is how most of us write our code, especially in Python. And uh, in asynchronous programming, we also have these two concepts called concurrency and parallelism. And in concurrency, multiple tasks making progress within overlapping time periods. So the best way to imagine this is using this illustration that I'm showing on the screen. Imagine you have the three tasks that we have previously, the blue one, the green one, and the orange one. So you're gonna start your blue task, and then you're gonna wait for it at the background, and then after you start your blue task, you're gonna start your green task, and then we're gonna start your orange task. So concurrency just means that you're gonna jump from task to task, looking for if your task is finished. So basically, for example, we started our blue task and it's not finished yet, so we can start another task. Maybe we can look back at our blue task here, it's not finished, so we can start our orange task, and then we're gonna go back to our green task, it's not finished yet, and we're gonna look at our blue task. Now maybe it's finished, so it's done, and then we're gonna look for other tasks to see if they are finished. So that's how concurrency works. You're basically jumping from one task to another, looking for if that task is finished. So on the other hand, on another concept in asynchronous programming, we have parallelism, where multiple tasks executing simultaneously, typically on multiple processors. So this is how it's gonna look like. You have three tasks here that are being simultaneously started, and if one of them finishes, you're gonna get maybe a result from that. But basically, you're starting your task simultaneously. In concurrency, you're jumping from one task to another, and in synchronous programming, you're waiting for one task to finish. Next is IO-bound task and CPU-bound task. So this is also important because this is what's gonna be your decision in what type of programming you're gonna do, or on how you design your code. So IO-bound tasks are basically API calls, right? You're calling an API or your backend API, your front end. Maybe you also have network requests such as accessing your database on another server, and file IO, which is maybe you're accessing a CSV file on your local file system, maybe you're accessing other files. And also, we also have CPU bound tasks where tasks that are CPU intensive, like um, data processing. Maybe you're doing LLM training, maybe you're doing machine learning, uh, maybe you're doing data aggregation, things like that, and also mathematical calculations. So these types of tasks are the most common, I would say, that we're gonna see, or that we're gonna encounter when we're trying to write code. So yeah, in here we have our libraries in Python, or our concepts in Python that are that I'm gonna give you examples later on. I'm gonna show you how to code these different types of synchronous, as well as we're gonna also show you synchronous code in Python. So first we have here Asyncio is a library for concurrent code using async and await syntax. And then we also have multiprocess in here, in which we can achieve parallelism by using separate memory spaces. And we also have threads, which is a way to achieve concurrency via threads within the same process. So don't worry about how what it is right now. I'm gonna show you how it's gonna be coded in Python later on. But we have different uses for this different and in asynchronous programming, we also have these two concepts called concurrency and parallelism. And in concurrency, multiple tasks making progress within overlapping time periods. So the best way to imagine this is using this illustration that I'm showing you on the screen. Imagine you have the three tasks that we have previously, the blue one, the green one, and the orange one. So you're gonna start your blue task, and then you're gonna wait for it at the background, and then after you start your blue task, you're gonna start your green task, and then we're gonna start your orange task. So concurrency just means that you're gonna jump from task to task, looking for if your task is finished. So basically, for example, we have here, we started our blue task and it's not finished yet, so we can start another task. Maybe we can look back at our blue task here, it's not finished, so we can start our orange task, and then we're gonna go back to our green task, it's not finished yet, and we're gonna look at our blue task. Now maybe it's finished, so it's done, and then we're gonna look for other tasks to see if they are finished. So that's how concurrency works. You're basically jumping from one task to another, looking for if that task is finished. So on the other hand, on another concept in asynchronous programming, we have parallelism, where multiple tasks executing simultaneously, typically on multiple processors. So this is how it's gonna look like. You have three tasks here that are being simultaneously started, and if one of them finishes, you're gonna get maybe a result from that. But basically, you're starting your task simultaneously. In concurrency, you're jumping from one task to another, and in synchronous programming, you're waiting for one task to finish. Next is IO bound task and CPU bound task. So this is also important because this is what's gonna be your decision in what type of programming you're gonna do, or on how you design your code. So IO bound tasks are basically API calls right? You're calling an API or your backend API, your front end. Maybe you also have network requests such as uh, accessing your database on another server, and file IO, which is maybe you're accessing a CSV file on your local file system. Maybe you're accessing other files. And also, we also have CPU bound tasks where tasks that are CPU intensive, like um, data processing. Maybe you're doing LLM training. Maybe you're doing machine learning. Uh, Maybe you're doing data aggregation, things like that, and also mathematical calculations. So these types of tasks are the most common, I would say, that we're gonna see or that we're gonna encounter when we're trying to write code. So yeah, in here we have our libraries in Python, or our concepts in Python that are that I'm gonna give you examples later on. I'm gonna show you how to code these different types of synchronous, as well as we're gonna also show you synchronous code in Python. So first we have here Asyncio is a library for concurrent code using async and await syntax. And then we also have multiprocess in here, in which we can achieve parallelism by using separate memory spaces. And we also have threads, which is a way to achieve concurrency via threads within the same process. So don't worry about how what it is right now. I'm gonna show you how it's gonna be coded in Python later on. But we have different uses for this libraries for these different concepts in Python. So for async IO, you use it for high performance I-bound applications like web servers. So previously, I gave you I defined IO bound tasks. So async IO is good for that, and multiprocess it's used for CPU bound tasks where computation needs to be distributed. So you need, if you have CPU bound task, multiprocess is the one to implement. And multi-threading, it's used for applications that are IO bound and require minimal data sharing. This one is the most I think most complex to implement because of a concept in Python called GIL, or Global Interpreter Lab. It's an advanced topic. Maybe it's gonna be our topic for another day, but it's one of those concepts that I also don't have many experiences with. So I think I can show you now a few examples um, of how these concepts look like in an actual Python code. So I'm just gonna switch to another scene here. In here we have an example for our synchronous code. We're just gonna import our request. We have a function here for calling an API. All of my examples are gonna be fetching from Poke API. I'm a big fan of Pokemon, so I think it's gonna be also a good way to show you how these different concepts can be implemented. Yeah, we have here a function for calling an API, and it's gonna return the response, which is in JSON format. And then we have a our main function here. We're basically gonna request Pokemons from the first Pokemon up until to the 5th Pokemon on the Pokédex, which is gonna be, I think, Bulbasaur. And we have here our empty results array, or empty results list in Python. And then we're just gonna loop through these 5 IDs, and then we're just gonna fetch that Pokemon, and then we're gonna append the result on our results list, and then we're gonna print everything. So let's try running this example here. Let's see here. Synchronous, excuse me. See here, we have our result now. It took our code 6 seconds to finish, so that's how long you're gonna wait for your execution to finish if you're using synchronous programming in Python. So we have our results here, and I'm right, the fifth Pokemon is Bulbasaur or Charmander. But here, we have our Pokemon's result here. The next example is gonna be concurrency, which is gonna be using Asyncio here. It's a default library in Python. We're also gonna use AIO HTTP, which you're gonna need to install. This is gonna be a library that you're gonna need to install. And we have here somewhat different implementation of our first function for fetching our Pokemons, or for calling the API that we were using. But in here, you're gonna encounter new keywords in Python, which is async and then await. Async in Python is you're basically telling your script that the function is gonna be an asynchronous one. We're gonna use different libraries such as AIO HTTP, and in our example, Asyncio. You're basically turning your plain old synchronous function into an asynchronous one. And await means you're awaiting for that asynchronous call. So that's the keywords that you need to know when you're trying to learn asynchronous programming in Python. So yeah, we have here our function for calling our API, and then in here we're just basically creating asynchronous task using this method of Asyncio called gather method. So this is pretty well documented. You can have a look on the different methods for the Asyncio library, but this is how I implement it. It's very basic right now. We're just trying to create a list of tasks for us to asynchronously execute. So when you try to run an asynchronous or Asyncio, you're gonna use this method from Asyncio. It's gonna be called run, and then you're calling your main function, which also needs to be asynchronous. And then when we try to run this, let's see how fast it's gonna be. Example concurrent. Also need to time it. It's gonna be faster. Yeah, it took us 1 second to get the results from the API. Also, let's go to the next example, which is multiprocessing. It's gonna go back to asynchronous function. In here, we're defining the same function that we have on our synchronous example, but this time we're gonna try running this on multiple processors. So yeah, it's basically the same function that we created earlier. We have here our main function, which we're just gonna create a pool of processes, right? You need to read more about this topic, but this is how I created this very basic example. I use pooling and multiprocessing. So I'm gonna create 5 processes in this pool, and then I'm gonna pass on this function that I'm doing, and then it's basically gonna call, basically gonna spawn 5 different processes at the same time. So it's gonna be parallel with one another. And then when we run this, I think we're also gonna be basically getting the same result as we have earlier. It took longer than the asynchronous one, but I guess this is because of the differences in latency. Maybe I'm wrong with that, but yeah, that's how multiprocessing is done on Python. And yeah, you can read about the multiprocessing library if you wanna go in depth with this concept. And yeah, lastly, we have multi-threading. I tried my best to create a simple multi-threading in Python, but this is one of the concepts that is hard for me to grasp right now at my current level, because of the one that I mentioned before, which is the JL, or the Global Interpreter Lock. But yeah, we have here the same function that we're using for multiprocess and synchronous, which just calls the Pocky API. And then in here we're creating different threads depending on the number of requests that we're trying to make. And in this case, 5 requests. And then yeah, we're basically spawning again 5 threads, different threads for each request, and then we're gonna printing the result. So let's see. Yeah, so more or less concurrent multiprocessing and threading, Asyncio, you're gonna get the same result for my example, or for my use case here, which is just calling 5 which is calling an API 5 times. So maybe you're gonna have different results for your use case, but this is the very basic implementation of those concepts that I talked about earlier. And hopefully my examples are not too basic, and hopefully I gave you new knowledge on how you're gonna use these different libraries in Python in your day-to-day when you're trying to complete a task, or you're trying to improve your code for efficiency. And yeah, that's all I have for today, folks, and hopefully you pick up something new from me, and see you on our next Tech Talk. Bye-bye. And there you have it. Thank you for joining us today. If you enjoyed this Tech Talk, be sure to follow us on Facebook, Instagram, LinkedIn, YouTube, and TikTok at KodeAcross. And you can also check out our website at KodeAcross.com. The links are going to be in the description down below. We want to hear from you. So if you have topics that you want us to cover, and you want to join us live at our Tech Talk, comment down below. And yeah, it's been meaningful apps that change the world. Thanks again. Bye-bye. There you have it. If you guys have any questions, you can comment it down below on our Facebook, YouTube, and LinkedIn. I'll be looking out for your questions. Let's see if you have questions, clarifications in this discussion. I'll be happy to answer them to the best of my abilities. Let's see. I hope my explanations are clear and not that complicated for everyone. Let's see. We are live on Facebook, YouTube, and LinkedIn, so I'll be looking out at your comments. You have. I'm gonna give you guys a few minutes to think about your questions if you have any. Let's see. So fresh. Maybe I missed something. So for a bit. Okay, it seems like we have no questions on Facebook, YouTube, and LinkedIn. So I guess we can end it our tech talk right now. So if you have any more questions that you can think of in the future for this topic, or if you have any more topics that you want us to discuss, you can reach us at Facebook, LinkedIn, Instagram, YouTube at KodeAcross, and we also have a website at www.kodeacross.com. You can reach us there, and yeah, that's it. And let's build meaningful apps that change the world. Thank you guys for tuning in.